next speaker of today, that will be Mr. Elliot Pines. He's a Bachelor in Physics, a Master of Science in Engineering, Ph.D. Electrical Engineering, and a volunteer at IWRI based in the USA. And his presentation will be about methods for improving personal and social effectiveness of a person. Oh, I'm sorry. His presentation will be about lessons from infinity for integral education. Well, Elliot, please go ahead with your presentation.
Okay, I'm going to grab share. Is my voice coming across clearly?
Yes, we can hear your voice.
Okay, great. Yeah, just to mention, I do have a PhD in engineering as well. Okay, I'm going to grab share screen now. And okay, great. Okay, you're all seeing that fine? Okay, terrific. Welcome to lessons from infinity for integral education. Apeirophobia, a fear of infinity, eternity. It's generally about imagining our endless non-existence or existence after death. It appears that the philosophers of ancient Greece had a different version of this fear, that of something intrinsically above reason, that anything even exists beyond finite comprehension. Infinity was banned from math and, of course, cosmology. In particular, the philosophers generally eliminated boundless reality by the creation of bounded ones. The radical monism school, however, countered this approach, claiming that no bounds could exist. All is one, so even space-time doesn't exist. And hence, there is nothing to divide, and so there are no bounds. In fact, Zeno of Elea of the school claimed that the idea of space, the idea of space and time themselves led to infinity paradoxes. Focusing on 6 of the surviving paradoxes and unwrapping them from their cultural clothing, the racetrack is a paradox of process trapped at the end of an infinite procedure. The Achilles is an infinite procedure paradox of unending differential process. The arrow is a 0 over 0 paradox. The stadium, thought a misunderstanding of relative motion, is really an infinity minus infinity paradox. And the divisible and the total are different forms of infinity times 0 paradoxes. These paradoxes appeared to be answered in the 17th century. Galilean relativity generalized the racetrack and the Achilles as infinite procedure paradoxes and appeared to explain the stadium. Calculus then seemed to explain these infinite procedure paradoxes as infinite series converging to finite displacement and time limits. Similarly, the point tangent slope of differential calculus appear to answer the arrow's 0 over 0 question with continuous velocity. Finally, definite integrals provided finite numerical values for the divisible and the totals infinity times 0 problems. However, this all fails 2 centuries later with the discovery of the Weierstrass function, where derivatives don't even exist. Integrating over non-existent derivatives, of course, does not reconstruct the function, and the infinite majority of functions are actually Weierstrass-like rather than well-behaved. This also may have inspired the following accounting trick of, I'm sorry, I don't have a graphic here of it, but conditionally convergent infinite series of real numbers. This series consists of an interleaving of plus minus infinity and minus infinity through alternating positive and negative terms within a series per the Riemann arrangement theorem. The commutative law of addition vanishes. One can rearrange the series to equal any real number from minus infinity to plus infinity, and the infinite majority of real number convergent infinite series are conditionally convergent. In any case, welcome to the great crisis of mathematics. Arguably, the greatest mathematician of the era, Hilbert, finally grasped the true depths of the problem and goes back to the absolute finite bounds approach of the ancient philosophers, but with a new twist. From his own contributions to relativity and quantum mechanics, he zeroes in on space-time, not matter, to try and directly counter Zeno's deadly assault on the very foundations of mathematical logic and scientific empiricism, reason itself. But the assault is far more subliminal and deadly than even Hilbert realized. In fact, Hilbert has only made things worse. His bounds abound with zeros and infinities galore, and I don't have time to go through these, but you can get a quick glance. This one's particularly cute. And really, Einstein thought to avoid them, but they're even in general relativity. These things were discovered after his death. Just let's take one look at a detailed example of Zeno's radical monism Trojan horse into modern mathematical thought and science. Quantum principle avoids the infinitesimals. According to Hilbert's observation, I thought it explained it with general relativity and quantum mechanics. Quantum principle avoids the infinitesimals of the racetrack Achilles divisible and total by effectively introducing a minimum distance. The reality of the stadium is relative speed ad infinitum into an infinity minus infinity paradox. However, with light speed limit, this is also avoided. Never get anywhere near infinity, right? Finally, the Lorentz contractions of special relativity involves contractions in space and time as one approaches the speed of light. Store the arrow's velocity information in its length.
I'm sorry, Elliot, to break in. Is it possible to speak a little bit slower? And that's for the translators. They have
I'll try. I just want to make sure the timing works okay. I should have enough extra time. I'll try.
You have time. Yes. Thank you very much.
Okay. However, infinite speed jumps over finite smallest distances. Infinite speed jumps over finite smallest distances do not go well with finite speed limit, nor with space contractions based on that limit, which sets us up for. In 1935, Einstein and two colleagues published a paradoxical thought experiment highlighting this entanglement problem as an ad absurdum proof of a breakdown of the quantum theory. However, to the contrary, this phenomenon was demonstrated in countless actual experiments over the past 40 years. On the other hand, these were all by indirect methods, allowing only perception of clear after effects. It's the only way that what is logically impossible to our minds could possibly be perceived, and Einstein's logic remains impeccable to this day. One technological result of this is the quantum computer, and that the arrow, now known as the quantum Zeno effect, might be used to shield its memory from the laws of thermodynamics, so to speak, while the arrow makes up its mind whether it's moving or not. In recent years, physical, life, and cognitive sciences have begun to strongly imply that our very perception of the universe that we seem to live in creates that very universe, is that very universe. To turn a saying of Einstein's on its head, it is not that the only thing incomprehensible about the universe is that it's comprehensible, but rather that the only thing about reality that we actually do comprehend is precisely why it is that the universe that we perceive is comprehensible. Anything that we are actually going to perceive, directly explore by our science is going to be entirely finite. And this has some amazing consequences and explains a lot of things. Every individual item is unique. All are connected and interdependent. All these relationships have non-zero variations to every perceivable order. And this is an important point. This slide is sort of a life and the ecosystems in a nutshell per our approach here, and some commonalities of several modern theories. This gets more into the next view graph as well. Read what you can of it. I'm sorry, as this is going to go somewhat fast for details, but basically, and this is the bottom line, the nonlinearity of relations leads to deterministic chaos, which allows for interscale communication and feedback. That is homeostasis, unfolding to the global. This is analogous to the phase lock process of communication electronics or brain entrainment. Seen these things online, internet, that's used for inducing learning, sleep, or hypnotic states. Grandfather clocks leaning against the same wall will similarly tend to synchronize. Higher consciousness and or proto-consciousness apparently makes good use of this communication. This is per Professor Donald Hoffman of University of California, Irvine Cognitive Sciences, and per the Hoffman-Penrose, for the Penrose-Hameroff theory. Professor Penrose is Professor Hameroff is professor of anesthesiology and psychology at Arizona University, and Professor Penrose, as many may know, finally won a lifelong achievements Nobel Prize in physics. Just to get a little flavor of some possible details of a causal story of life that we might surmise indirectly from after effects, of course, if the reality is our own construction. In the left column is represented electron flow, that is lightning-induced extreme nonlinear thermodynamics on the early Earth, powering the construction of benzene ring quantum resonance structures, which know how to use water and electric field for hydrophilic, hydrophobic alignment. In the middle column is represented as formations of membrane bodies, microtubule-based motor structure, and sensory and communication data and processing primitives. There's also a relationship to DNA, but I haven't analyzed that sufficiently that I want to speak about that yet. In the right column, bacteria, plants, insects, birds, mammals, and fish, etc., integrate into communities, eventually unfolding with others as the ecosystem, using countless varieties of electrical, chemical, mechanical, auditory, visual, gesture, you name it means at their disposal to develop integral communication. There is even a biological means. Mycorrhizal fungi interconnect plants in an amazingly complex manner that is being called the Earth's Internet. Now, we humans, with our complex verbal and body language and electronics, still allowing but the tiniest drips from our potential ocean of shared sensation and thoughts, what possibilities lie before us yet untapped? Finally, lessons from infinity for integral education. Our reality is our joint perception. That reality is integral. True advances in science and human welfare will themselves come about through intentionally furthering joint perception via integral communication and consequent integral action. As a side technical point, the interconnection crucial to the above needs to have its own special measures. There's already been some useful indirect research along these lines. We have something to build up on already that's been done. Last final thought. Is there not also one lesson from within infinity itself? If so, it would seem to be our way not to evade it, but as it were, connect with it in the only spaceless, timeless purpose it could have, unity. Do you see old Zeno smiling? Thanks for letting me share this with you. I think we have some time yet for questions.
Wonderful. Are there any questions for this presentation? Please answer.
I have probably a very small question about the possible infinity of our world, or just opposite the infinity of our world. What do you think if the effects that our world is quantum and relativistic, and it is finite, are those facts connected? And what is your opinion how they are connected?
Okay. Well, there was a very, very interesting thing about it. I did one quick review. I'm sorry it went so quickly. Basically, the Leibniz's law about identity and discernibles. And there's a modern version. I think the first person to bring that up, and just looking at a book that I had on it, it was, I'm trying to, it was a student actually of Roger Penrose, wrote a book called The Physics of Mortality. Actually back in 1984, it was quite popular. Bestsellers list. And in any case, in that he brings about emulation theory that in fact an emulation that is exactly in every detail and description of what it's describing is one and the same thing. In other words, there's no information missing. If I say triangle, it doesn't, there's no space or time connected with it. It is one thing. So the point is that if our world is finite, the world that we perceive is finite and everything is there. If I wrote a computer program or I described it, they are one and the same thing. If they're not, please tell me the difference. I'll include it in the program. In other words, obviously something's missing. In the same way, the integers are part of the real number system, etc. They're floating in there. So there has to be a higher level. This is it's a stronger basis of actually the simulation hypothesis. Other things, again, I mentioned Professor Hoffman's idea that in fact, this is all being produced evolutionary-wise by consciousness itself, and that, in fact, the entire world is a total illusion. There's nothing but conscious entities. Very interestingly, apparently, Professor Richard Dawkins, who's very, one of the strongest materialists around today, is favorable towards the theory and accepts the fact that perhaps his ideas of random mutation, etc., go back to a higher level. In fact, abstract principles, these laws of the universe, that we mention here. So there's an interesting coalescence here of what were classically religious ideas and non-religious, of atheistic ideas, we might say, that are coalescing to maybe a deeper truth here. But in any case, the very fact that if we're finite, we're floating in something. In other words, the finiteness implies a higher level. And of course, the higher level implies a higher level and so forth. So it would imply some sort of continuum into infinity. What that would be, all I can say is that in the 19th century, in the great crisis of math that was mentioned, one of the players now was a gentleman by the name of Cantor, who developed a system of transfinites. Hilbert himself was very supportive of this, which interestingly, because he thought it was a mathematical abstraction to play with infinity while denying it in physical world. He was broken in two ways. One was by Gödel in 1931, which showed a plan that he had for doing this finite mathematics was destroyed. Also, if you look at Cantor's method, it is an intuitive method, not what's called realism in mathematics, because it involves an infinite construction. Now, I can take, I don't want to go into this too much, but if you take what's called the diagonal method, what I can do is one-for-one correspondence. I can produce all the whole numbers and then map those, just mirror them across a decimal point to get all the real numbers from 0 to an open set of 1. Okay, and therefore I can apply the same rule. Now, what happens is, well, where is those magic numbers coming from? At 0.9999999, and it never reaches. But the point is that I have diagonal methods showing that I can't make a list in the integers themselves, or else that I can make it. I have a procedure here to produce all the real numbers in that area. So we see already the contradictions when you play with infinity. It's very similar, as I said, to the infinity minus infinity in the that special kind of convergent series I mentioned. I'm sorry, I forgot the term myself, but it's infinity, where you have alternating terms of plus or minus. And as Raymond showed, it's a really great game. You want me to make it pi log of 2 plus infinity minus infinity 2,000,000,016, anything, it's like the accounting trick. You close the windows. What would you like it to be? So it's a game when you start getting to infinities. I would say the only thing representative of infinity, if there was one rule, free will. I'm not I'm not saying as a religious thing, as a math, as you wish, but I have no other way to describe it, because no other rule or law applies to absolute infinity itself. Everything is a game that mathematicians play, and they realize that, really. I've spoken to mathematicians, they dust it under the rug, but there's all sorts of problems. The Banach-Tarski, problem, you can cut apart a ball in a finite number of pieces and reconstruct it as large as you like, which probably involves some sort of fractal combinations and such. I don't know. I hope this answered the question, and I'm sure we're out of time by now.
Thank you very much. Well, I see a raised hand by Joshua Johnson Umizulike. So we do leave some time for this question. That will be the last. And please, Elliot, if you answer, to speak slowly for the translators.
My question is very simple, Professor.
I really do apologize. I was afraid of the time. Yes, please.
Professor, I wanted to see what you think about this. So what do you say to the statement that the notion of infinity could possibly be an abstraction of human mind in order to understand the world? Can you elaborate and explain a little bit on this?
Well, the thing is that we really we don't know anything really about infinity, except in an intuitive manner. Gödel himself claimed that he felt that there was a validity to intuitive math, even though he contradicted Hilbert, that he himself believed in an intuitive idea of mathematics. And that there was, in other words, as we physically see and perceive things, that intuition was a form of perception too. I mean, one can go all the way on this thing, because one has, in that notion of intuition, there's of course the eureka phenomenon, etc. And one could say it's a lower level of what we would call, let's say, some sort of holy vision prophecy, or it would validate the possibility of all this. I don't know. But in the end, as far as infinity, we have nothing to say about it. All our tools are logical and a finite limit. It violates all laws of arithmetic. If probability, if I have a box of red and blue balls, let's say, and an infinite number of red and infinite number of blue balls. So I say, what is the probability I reach and I'll pull out a blue ball? And I say, well, you know, infinity. So it's 50-50. No, I forgot. I have 9 infinity of blue balls and 1 infinity of red balls. So it's 90%. No, I was wrong. It's 9 infinity of red balls and 1 infinity of blue balls. So it's 0.9%. It's any probability and probability statistics is meaningless. Arithmetic, you know, the infinity minus infinity is anything you like. 0 over 0, it's anything you like. In other words, it becomes a line. The solution is not a point, but a line. It's qualitative because there's no weighting or any values to points. So except what we might grasp intuitively if there is something to prophecy, etc., or eureka phenomena, whatever the human mind guess, a higher still, you know, it comes down to us from infinity, but we're getting it in some sort of finite way. So, you know, I don't know what to tell you, but we don't know. I mean, there's nothing from our logical world to go out and start to we'll figure out infinity or determine if it, you know, whatever, you know, as the Greeks tried. No, I think Zeno had tremendous intuition about the man, and so does teacher Parmenides. But I can't tell you what they actually meant. I'd have to be living 2,500 years ago to be sure.
Thank you very much, Elliot. That was very wonderful.